Notebook, page 248. Blue Notebook, page 253. Yeah, that's right. Lesson 5.6. I wanted you to write down all of the key concepts in your notes. They're important for today's lesson. We're going to jump ahead to example 3, okay? This is factoring a perfect square trinomial. I'm going to quickly talk about what the book is discussing, and then I'm going to show you how the stuff we've been doing the last 2 days we can use again today to do this stuff. So the book is going to talk about a perfect square trinomial, so they want you to be able to recognize something. They want you to be able to recognize 2ab plus. Oh, sorry, they don't use an x, they use an a. My fault. Okay. What they want you guys to recognize is you have an a squared, a, and we call this a b, and b squared. So, I know this is a little different from what we're used to looking at, but the idea behind this is they want you guys to be able to recognize that your very first term, a, is the square root, okay? A perfect square. So we have a whole number as a square root. So in this instance, they want you to find the square root of your a. In this instance, we have 4. Square root of 4 is 2, okay? So we know that's a perfect square. That's good. Now, they call it b. We're used to calling it c, though, okay? They want you to know that c, or they call it b, is also a perfect square. So 49, I know is a perfect square. I can use 7 times 7 to get to it, right? Now, what's very important about that is to make sure this is a perfect square, we need to be able to take the square root of our first term and our last term, and whatever those answers are, we multiply them by 2. Once we do that, if it equals 28, it's a perfect square trinomial. There's not a lot to remember the way the book presents it. I'm going to show you how this can be a little easier, but I'll show you quickly what the book's talking about. So I take the square root of 4, I get 2. Square root of 49 is 7. So I put the numbers 2 and 7, and I multiply them by 2. 2 by 2 is 4, times 7 is 28. If you guys notice, it's the same 28 from there, okay? That's recognizing a perfect square trinomial. For argument's sake, we don't need to do that. We're going to do the exact same way we've been doing it the last couple days, and I'm just going to show you how to change your answer at the end, okay? In a perfect square trinomial, what they're going to tell you is your final answer is going to be only one bracket, and it's going to be your square root plus 7 squared. They're going to have a little squared at the end of the answer. We're going to eventually get to that, okay? So we'll do ours the way we've normally been doing it. So I'm going to rewrite this question. 4x squared plus 28x, 49. We have our x squared, our x. Don't worry, I'm going to put the a's in, don't worry. Oh, thank you. I'll get that. There's our b, and we're going to go back to our a, b, and c. That way we don't get confused from the way the book had it. And thank you, it's supposed to be 28, not 2. Okay, so if you guys notice, we have our A, which is 4, our B is 28, and our C is 49. We're going to write back the essay. I'm going to work through this quickly because we've been doing this for 2 days, so I expect you guys to be pros by now. Factors of A are 1 and 4, 2 and 2. Factors of 49 are 1 and 49, and 7 and 7. We know that when we multiply our columns, we need the products to add up to our B, which is positive 28. They all need to add up to that. So, make our columns, make this a little more organized. Now, I know by looking at this what my answer is going to be. So I'm going to just go straight to the answer. Let's say you guys have tried all your options, and you guys finally figured out that 2 times 7 and 2 times 7 gives you 14 and 14. They add up to positive 20. So, now that I know that, we know that our answers, right? Sorry, let's circle our columns that we're using now so we know this. I'm using this column here, 2 and 2, and this column here, 7 and 7. So because we're using those, we can put our terms into our brackets. By the way, there was no common factor. I forgot to say that first. Remember, we always look for a common factor first. My first term is 2x, and my other term is 2x. Turn out to be the exact same. Great. Nice and easy. My last terms. Now, technically, I got to put them in opposite brackets, but because they're the same number, it makes no difference. So 7 and 7. In this case, we had positive 49, and these both need to be positive. That means positive 7 times positive 7 is positive 49. And when we multiply, we would have gotten positive 14. Added together, positive 28. So both of these are positive. Okay? So factoring it the way we've been doing the last 2 days, we've gotten to our answer. They just want you to represent it a little differently. If you notice, both brackets are the exact same. So instead of writing it as 2 brackets, just write it as 1 bracket squared. Okay, now let's go back to example 1. We're going to be talking about a difference of squares. If you guys notice right away, a difference of squares looks very, well, not very, but looks quite different. That didn't work out. Let's try that again. There you go. Looks quite different from what we were doing before. There really is no b involved, okay? What's very important is I need you guys to recognize that there is a negative sign in between. Hence the title, difference of squares. That's why they call it a difference. They're talking about a negative sign in between 2 terms. The next thing you need to recognize is that your first term is a perfect square, x squared. Quickly, what would be the square root of x squared? X. Good. And that your second term is also a perfect square. What would the square root of 100 be? 10. It's very easy. Okay? So you guys have noticed that already. Good. I'm going to write out our theory model or theoretical model we normally have. They have called it, they just use 2 letters. Okay? So they use in their model a squared and they use b squared. Okay? Those are the 2 letters that they use, a little different from what we're used to using, and a difference of them. What they tell you is a squared minus b squared is equal to a plus b, a minus b. That's going to be the factored form. You know what? Let's write those in color for you. Yeah, really easy to see already, eh? So we have our a and our a, and our b and b. Okay? So our theory model is a squared minus b squared is equal to bracket a plus b and bracket a minus b. So all we have to do now is make sure we can recognize these in the equation. So I'm going to rewrite example 1. X squared minus, very important, 100. Can I find the square root of x? Let's do it on the side. What is square root of x? Easy. Can I find the square root of 100? Yeah. 10. Look at that. Whoa, that's not 10. There you go. So, I have a square root of my first term and a square root of my last term, and I have a negative sign. That's it. I'm pretty much done. I just have to plug those numbers in. So my first term in the numbers is always going to be the square root of our a. In this case, square root of a was x, so we put in x as the first term. Our last term is going to be the square root of our b, and in this case, our b was 100, so we got 10. And I just put a plus and a minus sign. And I'm finished. So my answer is x plus 10, x minus 10. Talk about it one more time. So, like we said before, if you guys notice, this is a very special case. We're used to seeing, and I'm going to quickly write it out. Let's say, we're used to seeing x squared plus bx plus c. I didn't put the colors in this time, sorry. So we're used to seeing ax squared plus bx plus c. This is what we're used to seeing. Oh, it didn't work. Unlucky. Well, in this case, though, we have an a squared plus b squared. Sorry, a squared minus b squared. Okay? That's what the big difference is. There's only two terms, and very importantly, there is a negative sign there. Please don't get that confused. You may get a question on your test that has a positive sign in there. Would that be a difference of squares? No. Okay? So the first term we can find a square root, the last term we can find a square root, and they're subtracted. Okay, example 1b. So example 1b. This is, by looking at it, it's a binomial, and I have a subtraction sign in between. So first thing I want you guys to think of when you see that is that it is a difference of squares. Now when I look at it, 98 and 450, I can't quite find the square root out of those, but that's not my first step. My first step is to always look for a common factor. So I look at these, I know that 2 is a common factor for both. So I put the 2 on the outside, and I have my brackets, okay? When I divide 98 by 2, I get 49, a squared. I divided this by 2. And when I divide this by 2, subtracted by 225, b squared. Okay? Now when I look at this, 49 and a squared. I can find the square root of 49, and I can find a square root of a squared. So the square root of 49a squared, anyone know what it is? 7a. I can also find a square root of 225 b squared. What is it going to be? 15b. I know that's a larger number to find a square root of. That's why you guys are allowed calculators. So I can find the square root of the first term and the last term, and what sign is between them? Negative, so, or subtraction sign. So I know it's a difference of squares. So my next step, common factor on the outside. First term is 7a in both brackets. Last term is 15b in both brackets. Plus, minus. Finished. Okay, homework. Page 255 to 257. That is all of your homework. Good luck on your literacy test tomorrow.